So we're going to start off by discussing relations and functions. And so when we're talking about a relation, it is just a set of ordered pairs or inputs and outputs, x and y's, domain and range. Okay, a lot of different ways that we can describe that. But when we look at a set of ordered pairs, the first component is the input or the domain. So here, 1, 2, 3, 4, 5. Okay, those are the first component or element of the ordered pair, which we're calling the domain. And then for the second set of the components, all right, we call of each ordered pair, that's the range. So 2, 4, 6, 8, 10. All right, and that's the range here. So when we represent them together as a set, these brackets here tell us that we're working with a set, all right? And each of these sets of inputs and outputs is an ordered pair. A lot of times we also want to know, what is going on with the set of inputs. So we want to have a word to describe just the inputs, and that's the domain. And then we want to be able to have a term that describes the outputs, and that's the range. So when we're talking about relationships and functions, we have a number of ways to represent them. Here, so right up here, we represented them as a set of ordered pairs. We can also represent them, as you see here, as a set of inputs and outputs. This table here, this is an input-output table, all right? So we put all the inputs, 1, 2, 3, 4, 5, and then the outputs that go with it, 2, 4, 6, 8, 10. And when we're talking about inputs, another way to describe inputs as the independent variable, they both start with IN. So when I input 1, I get an output of 2. And so these are outputs or a dependent variable. The Y value depends on what do I input for X. So another important way that we can represent relationships or data and functions is to graph it. So all I've done over here is I've just graphed these ordered pairs. So 1, 2. All I did here was take when x equals 1, y equals 2. 1, 2. All right. Down here, when x equals 5, y equals 10. So I plotted that point. So I can graph every one of those ordered pairs here. And when I do that, I want to look to see what kind of relationship. And a lot of times what I want to do is I want to create a graph and I want to see, well, what does that relationship look like? In this case, it looks linear. The relationship between the inputs and the outputs looks linear. And then in many cases, what I want to do is I can represent that relationship with an equation or a formula. This line I can actually represent as f of x equals 2x. So when I input 1, so f of 1 is equal to 2 times 1 equals 2. So when I input 1, I output 2. When I input 1, I output 2. F of 2 is equal to 2 times 2 is equal to 4. So every time I tell it what x value I'm inputting, I just substitute it in the equation. So when I input 2, I output 4. All right. So the question is then, how do we know, we talk a lot about functions, how do I know if a relationship is a function? Well, let's take a look here. So there's a specific definition for functions. And when I'm talking about a function, it's a particular kind of relationship. Not better, not worse. It's just there's just a definition that goes with a function. And when I have a function, it means that for each input, each input has exactly one output. Okay, so when you have an input, it can't have more than one output, otherwise it's not a function. So if I look here at this relationship, I've got my inputs and outputs. When I input P, I output M. I can write it as an ordered pair here. When I input P, I output M. When I look at Q, when I input Q, I get an output of N. And then when I input R, I get an output N. So this is actually okay because all of my inputs have only one output. So this is a function. If I look at this relationship, when I input P, I output X. When I input Q, I output Y. When I input R, I output Z. All right, so this is also this relationship is also a function. Let's look at this last one here. So when I input P, I output X. That's my first one. But when I come down to this next input of Q, sometimes when I input Q, I get Y. And sometimes when I input Q, I get Z. So I have a single input of Q, but it has two different outputs, Y and Z. So this is not a function. If I have an input, it has to have a unique output. All right. Let's talk about function notation. Okay, so function notation is just a way that we can translate words into math language or math language notation into words. And so if we're talking about defining a function, we have a particular notation, y equals f of x. All right, so this we read as y is a function of x. And the thing that's inside the parentheses is always the input. The thing inside the parentheses is the input. All right, and the thing on the other side of the equal sign is the output. So if I want to translate this here, y is, okay, a function, that's my f, of is the parentheses x. And I can also say that y is the output is equal to f of the input, right? So I can also write it, here I wrote y equals f of x. I can say f of x equals y. And if I translate that, f is my function, all right? The parentheses set, I write or I describe as of x, the equal sign, all right, is equal to y. So I say the output y is a function of the input x. Another way I can say that is the value of y depends on the input x. And if we go back to our example from before, this function here, if I say f of x equals 2x, this just means that, let's come here, my input, if I input -1, f of -1, everywhere there's an x, I'm going to put a -1. F of -1 is equal to -2, which is my y value. So when I input -1 for x, I get an output or a y value of -2. F of 0, okay, when I input 0 into my function, 2 times 0, I get 0. When I input 0, I get an output of 0. Okay, f of 1, when I input 1 for x, I get 2. I get an output of 2. The last one, when I input 2 for x, 2 times 2 is equal to 4. So the output value I get depends on what did I put in for x. We're going to dive more into this as we go forward.